Good morning to all Wikipedia YouTube videos. In the data section playlist, today we are going to add another video. This is going to be another sorting algorithm called as the insertion sort. Today we will see about the concept of insertion sort along with the second video, continuation video of implementation of insertion sort through a C program. Now first let me start with what is a insertion sort. Insertion sort is a sorting algorithm where the elements are taken from unsorted item, and then we will take a particular random item, try to find out where it has to be placed at. Like it works like simple like playing a card. While playing a card, you take a particular card and you try to find out the particular position where you want to insert it to keep it in ascending order. Let's say that if you have a card called card number 8, then you will be inserting in between like the number 7 and 9. Like that we will be finding a particular position where you are going to insert it, and that you are going to insert your data. This is the logic of insertion sorting. It is simpler to implement and usually consists of two loops. It is the runtime of this insertion sort is also order of n square. It will have two loops, the outer loop and the inner loop. In outer loop picks the items, the random item that you are going to pick it up. For that you will be using one outer loop, and the inner loop is like finding the correct position where you want to insert your data, insert your picked item into that sorted array. It works by a principle of sorting, playing cards in our hands. Insertion sort, how it works, it split our data into two groups, sorted group and unsorted group. Initially, first element is considered as a sorted one. It will pick data from the unsorted group and put it in the right place in the sorted group. Right. So it is going to split your data into two arrays, sorted group and unsorted group. So you are going to pick one item from the unsorted group, and then you are going to find out which was the right place to put it in the sorted group. Start with second element of the array, assuming first element is already sorted. So which means that you are assuming first element is under a sorted group and second element is under a unsorted group. From the second element you will be taking and you are trying to find out where you want to put it the sorted element. Compare second element with the first element and check if the second element is smaller, then swap both first element and the second element. Now after putting both first and second element into the sorted group, then move to the third element and compare it with the first two element. That is like every time whenever you take a card, you try to insert it in the correct position within the sorted group, which means that you will always be comparing with your already sorted part of your group and checking where has to be put it in correct position. So this will be repeated until all the array is sorted. So key concept of algorithm, first one, assume your first element is already sorted. Second, pick the next element and store it as separately in a key. So you are going to take an one element from unsorted group, and that is going to be considered as the key. Now compare the key value with all the element in the sorted array. So you already have a sorted array. In that sorted array, you will be trying to check where you want to insert your data into it. So for the first iterations, there is like only one sorted element will be your sorted array. That is your first element. So you will be trying to compare this key element with your sorted element. If you want to swap it, then we will swap it. Otherwise, you will leave as it is and you will be moving to the next two elements. If the element in the sorted array is smaller than the current element, then move to the next element. Else, shift greater element to the array towards the right hand side. Now what we will be doing it like, you have a sorted array and you have an unsorted array. From the unsorted array you will be taking a particular element that is called as a key. So you will be comparing with that sorted array elements, and if you find it out that sorted array element is smaller than the current key, then leave as it is. If the sorted element that is greater than the current element, then what you have to do is like you have to swap it, which means that you have to swap this key value to the sorted array, and you have to swap it that element, that greater element towards the right hand side, like bubbling it up. Step 5, insert that value to the current position where you want to have it. That is like if you are swapping it, then insert that key value to the correct position value in the sorted array. So this will be repeated for several iterations until all the elements in the array are sorted. Now let me go with an problem. Consider that these are elements we have at 12, 31, 25, 8, 32, and 17. So these are all unsorted element. So first what we will do it like we will assume we have two types of array, sorted array and unsorted array. Initially you will be considering first element as the sorted element. So you are going to consider it first element as the sorted element and the remaining list of element as the unsorted element. From this unsorted element, you are going to take a one particular element that you are going to say it as a key, and then this key will be convenient will be compared with your sorted arrays. Then try to find it out where you want to insert your data correctly. Now, first you will try to take two elements, that is like this is like one sorted element and this is your key element. You try to take two elements and try to find it. Initially, the first two elements are compared insertions are 12 and 31. So you will be checking up here whether 31 is greater than 12 or 12 is greater than 31. Here 31 is greater than 12. That means both 12 and 31 is already in ascending order. So far now 12 is in sorted order. So there is, you can mark it out as it in a sorted array. So here whenever your data is said to be in sorted order, I will be considering, I will be marking it in green color. Now once it has been done, we will be moving to the next two element, that is like 31 and 25 marked in blue color. Now in comparing it, we will be seeing it like 31 and 25. 31 is greater than 25. So what we have to swap it because we are going to sort your data in ascending order. So which means that smaller element always should be in the left hand side. So you will be swapping 25 and 31. So 31 is not a correct question. Now swap 31 with 25. Along with swapping, you will be also be comparing with your already sorted elements. So here 25 is and 31 are sorted. But then after that, you will also be comparing with your remaining sorted list of elements. So 12 and 25. Yes, 12 is greater than 25. So leave as it is. So if it is not, then you have to swap it again. Now, as a list, we have 12 and 25. Both these data are sorted. Now we will go to the next two element, 31 and 8. So again, we will try to compare it. 31 is greater than 8. So what we have to do? You have to move this greater element towards the right, which means that you have to swap 8 and 20, 8 and 31. So once you swap them, it will become 12, 25, 8 and 31. So as already mentioned, after swapping it, you should also compare this element with the remaining list of remaining list of sorted elements also. Here there will be a violation. So 25 and 8, when you try to compare it, 25 and 8, when you try to compare, this is unsorted. So swap, which means that 8 will be moving towards one step towards a list. Again, compare it with the 12 and 8. So 8, again it is a smaller one. Again, so move it towards the left. Now after that, you have your three elements that is in sorted order, 8, 12 and 25. 8, 12 and 25. Now try to take the next two element, 31 and 32. So try to check it out. 31 and 32 is already in sorted order. So what we do it like, we will be moving to the next element. So when you try to check it out, always also check it out with your remaining sorted list of items. So when you try to compare 31 with the remaining sorted list of items, 31 is greater, so it has to be placed as it is. Right. Now try to go with the next two items, 32 and 17. Here 32 and 17. 32 is greater than 17. So what we have to do? We have to swap it. So 31 should be coming here and then 17 will be going here. Right. Now when you do it, 31 and 17, it has been swapped. So now again there is a violation. So you have to swap 17 and 31. When you try to swap it, again there is a violation between 17 and 25. So what we have to? Yes, we have to swap it so that 17 moves one step towards the left hand side. Similarly, what we have to do it like you will be comparing 17 and 12. So here there is that was already in sorted order. No need for swapping. That's it. So now the array it is like in sorted order, right? So the key concept is like every time you will be taking from the first from the for assuming it your first element is already in sorted, you will be taking two elements at the same time. So first element you are going to take it, and second element you are going to consider it as a key. Always place your key that is the greater one, that should be in the right hand side. So if it is in sorted order, then you will be moving to the next two element. Repeat the same. If it is in sorted order, always also check with the already sorted data also. Like that, try to repeat it until all your data is getting sorted. So this is how your insertion sort works, right? So thank you for watching it. Please subscribe it, like it, and share it, and give your comments and feedbacks for improvement. Thank you.